Okay, Year 12 Maths Exercise 4B. We're going to do some long division today. You might have nightmares of this from primary school, or you might have been really good at it. I don't know. Let's have a look. But the difference between this and primary school is the fact we're going to do it algebraically. So first of all, let me remind you what you're meant to know about division. Now, long division is meant to look like this, and there's two types of division where you would have seen us at primary school. You might probably call it the bus stop method. Lots of schools do, but you kind of at the bus stop method very often did 8s into 25, and you would have said 3, and you squeezed a 1 in there, and then 8s into 16 go 2, and there's no remainder, so that's the answer. The difference between that and long division is we're complicated questions. It gets very, very busy here if you're not careful with those remainders. So what you're meant to do is 8s into 25 go 3, and you're meant to go 3 8s are 24, and you kind of put that sum underneath and you take away. 25 take away 24 is 1. So notice I've got the same result there. I've got 1 left over, but you just show you working out. Now it's not so bad when you divide them by 8, but on a more complicated number it might be more useful. You then bring down this 6, 8s into 16 go 2. Again you're then meant to go 2 8s are 16, take one away from the other, and when you get a 0 at the end, haha, this is what I'm looking for, that tells me that it worked perfectly. There was an exact answer. But take this one here, 6912 divided by 24. How many people know their 24 times table? I suppose this is the question. 6912. So if I was doing this, you see, 24 into 69. Well, I know it goes twice. 2 24s are 48. And therefore there are 21 left over. See, 21 might be a bit crowded if I try to squeeze it in. I'll bring the 1 down. Now I'm going to guess that 9 24s is that 216. It sounds a bit big to me, so I reckon it's 8 24s, and 8 times 24 I think is 192. Let's just check that. 192 is right. So mere fact I had to do it on the calculator to check tells you how rubbish this is. But anyway, so I've got 8 left over there, 11. I reckon there are 19 left over as when I take it away. And then now bring the 2 down. Oh, 192 again. I know that 8 24s are 192. Right there at the bottom. Take it away and notice I've got exactly 0 left over. And I suppose I could write this as 6912 shared by the 24, and it equals 288. That's the method of long division. Hopefully you can do the other 3 in this similar way. So we're going to do algebraic long division, and hopefully this will make sense. So let's have a go anyway. So we've got x minus 4. And I'm going to do algebraic long division, which basically involves exactly the same thing, but I'll write x cubed. Notice I divide them by x minus 4. The smaller thing's always going to go here. And then this longer thing will go under the line as it normally does. And I'm going to say, now look, listen to what I'm doing and try and make sense of it. I say, what do I do to the x to make it into x cubed? And the answer is I times by x squared. And I only look at that first term. But then when I do that back multiplication, which I did before, I do times both of them. So x squared times x is x cubed. And x squared times the minus 4 is minus 4x squared. And I want you to listen to this. I'm going to put this into a bracket to remind me to take away. It's very easy not to do that. So I put it into a bracket to remind me to take away. Now x cubed take away x cubed is nothing. That's what I wanted it to be. Minus x squared minus a minus. Notice minus and minus is a plus. So really this is minus 1 plus 4 is 3x squared, a positive 3x squared. At this stage you have to bring down that minus 11x. And I go back over here and I say, what do I times the x by to get 3x squared? And it should be obviously plus 3x. And 3x times the x is indeed 3x squared. But then I have to times both things. So 3x times the minus 4 is minus 12x. Put it in a bracket to remind you to take away. 3x squared minus 3x squared is nothing. Good. Minus 11. Minus a minus. Well, again, that's a plus 12x. So I reckon I've got a plus x left over. Bring down the minus 4, which luckily is exactly what I've got over there. So I can write, what do I do to the x to get x? Well, I times it by 1. And 1 times the x is x. 1 times the minus 4 is minus 4. And I get nothing left over, which is what I wanted. So the answer here, now this is important, if I ever did x cubed minus x squared minus 11x minus 4, and I chose for some strange reason to divide it by x minus 4, the answer is the top row from my bus stop, x squared plus 3x plus 1. And that's what we saw in normal division when I did it with numbers, and now with algebraic division it's the same technique, and that's the answer. So here's another one. So I'm going to divide this time by 2x minus 1. So it's slightly different as much as it's got a 2 at the front. You have to take that into account when you're doing this. So I'm going to go into 2x cubed minus 5x squared minus 14x plus 8. So what do I do to the 2x this time to make it 2x cubed? And you should be able to say, oh right, it's times by x squared again. X squared by 2x will give me 2x cubed. X squared times the minus 1. Notice you have to do both of these things. Always, always, always. X squared times minus 1 is minus x squared. Put it in the bracket to remind me to take away. So 2x cubed minus 2x cubed, well, it disappears. Minus 5x squared minus 5x squared. I reckon that's minus 4x squared. Bring down the 14x. It says minus 14x, in fact. So what do I do to the 2x to get minus 4x squared? Well, I think I've got to times it by minus 2x. That would give me the 4x squared, and then it's got a minus, so it will be a minus. So now I do that times in, and that will be minus 4x squared. Of course, that's the reason why I'm doing it, so these two things disappear. And minus times a minus will be a plus 2x when I times those. Put it in a bracket to remind me to take away. That take away that will disappear. Minus 14 minus a plus 2, I think it's minus 16. It's very easy to get those wrong. If need be, get your calculator out and do it. Bring down the plus 8. So, what do I times the 2x by to get minus 16x? I reckon I times by minus 8. So minus 8 times that gives me minus 16x. Minus 8 times minus 1 gives me plus 8. And you can see I got the same answer. So when I put it in the bracket to remind me to take away, I take them away and I get nothing left over. And that's what I wanted. So this up here is my answer. So I should have, oops, I didn't have, it should say x squared minus 2x minus 8. Okay. Next one. Now, polynomial division, that's just a posh name for what we've just done. But notice it says we've got non-linear denominators. That's because I'm dividing by this time. So let's have a go at this. This is a bit more tricky, but not much. Probably be finished quicker as well. So I'm dividing the big one, 2x cubed, plus 9x squared, plus 5x, minus 6, by this x squared thing. So the same trick. What do I do to the x squared to get 2x cubed? Well, I think I've got times by 2x, you know. Because that will make it go up to x cubed and I need a 2. Yeah, that makes sense. 2x times by the x, first of all, times by that. So that gives me the 2x cubed. That's what I wanted. Now I do the 2x times by the 3x. That's plus 6x squared. 2x times by minus 2, minus 4x. Put it in a bracket to remind me to take away. That take away that disappears. That's the whole point about doing it. But 9x squared minus 6x squared is 3x squared. See the importance of this minus here, because it'd be dead easy to add those there. 5 minus a minus 4, I reckon that's plus 9x. Bring down the minus 6. Now again, you go back over here and say, what do I do to the first term, x squared, to get 3x squared? Oh, well, times by plus 3. 3 times 6 squared is 3x squared. 3 by the 3x is 9x. Oh, you can see this is all going to be the same, isn't it? 3 divided by minus 2 is minus 6. Put it in a bracket to remind me to take away, but really I knew it was going to be 0. So my answer to this question is the top row, 2x plus 3. Let's see what it says as an answer, 2x plus 3. There you go. I've got another example for you. This is, right, now it says one factor of this is x plus 1. Use polynomial division to find the other factors, sorry. So I've got this, and it tells me that x plus 1 goes into it. Well, let's divide it. Let's see what I get as an answer. And this is really all I'm doing. It's worded in a way that makes it seem different. But I don't think it is. 3x to the 4 minus 2x squared minus 1. Ah, that's interesting actually. Look, it goes x to the 4, then x squared. It's missed out a few. I'm tempted, you know, just to do this instead. And see if you can spot the difference of this. So I'm now going to say x plus 1 into 3x to the 4. And rather than writing this, I'm going to leave a gap. I'm going to write minus 2x squared there. And this effectively is for the cubic terms, which may turn up in a bit. There's no x's, so I'm just going to write that. I'm going to get rid of this one because I think this would cause me problems. So notice the gaps if you've got powers which are missing. Let's do it anyway. X times by what gives me 3x to the 4? Well, I reckon that's 3x cubed. And 3x cubed, you've got to times by both things, so that will give me 3x to the 4. Times by the 1 gives me plus 3x cubed. And you see how that now fits into this gap. If I didn't leave that gap, where would I write it? Put it in the bracket to remind me to take away. That take away that goes. And this gives me nothing minus a 3x cubed is minus 3x cubed. Bring down the minus 2x squared. Okay. What do I times the x by to get minus 3x cubed? I reckon that's minus 3x squared. Okay, so 3x squared times that gives me the minus 3x cubed I wanted. And minus 3x squared times 1 gives me minus 3x squared. Put in the bracket to remind me to take away. And that minus that disappears. Minus 2 effectively plus a 3. I reckon that's plus x squared. Bring down that minus 1, a bit of a gap before it. So what do I times x by to get x squared? Well, I reckon that's plus x. X times by x is x squared. And I do the other one. X times by the 1 is plus x. Put it in the bracket to remind me to take away. It's more important, that's the sentence now. X squared minus x squared disappears. Nothing minus an x gives me minus x minus 1. Finally, I think this is the last time. What do I times the x by to get this? I reckon minus 1. Minus 1 times by the x is minus x. Minus 1 times the 1 is minus 1. You can see when I put it in the bracket to remind me to take away, I'll get 0. So this is actually my factor. It's not a very nice factor. That may factorize again, I don't know. But I think that's what I want. It says find the other factor. This is the other factor. Well, at least it might be. We'd call this a cubic factor. As opposed to this. When you just have one like this is a linear factor. And of course you can have quadratic factors as well. Now let's see if that's the answer I get. Yes, it is. So I'm just saying effectively, when you divide this by this, this is the answer you get. 3x cubed minus 3x squared plus x minus 1. So yes, perfect. But I suppose a lot of people wouldn't have known to stop there. I suppose that's the thing. Now I've got this for you, but I just want to highlight there is another method. And it's called the kx method. And it's quite handy. So I'm just going to quickly show you this. And perhaps then we can ask the question in class as to how to use it quicker, because it is a quicker method. Look, if I divide x cubed by x, the ones we've seen already, you get an x squared answer. So you're really saying that x minus 1 times by something has got to equal x cubed minus 3x squared plus 4x minus 2. And what you're really saying is, hang on a bit, I know that I kind of know what this thing here has got to be in order to get my answer. So although it says divide, I'm going to look at this as a multiplication problem. I suppose it's the same as it's saying if I knew that 6 divided by 2 is 3, I could also write that 3 times 2 is 6. That's really what I'm doing here. Yes, I've got to divide by x minus 1, but I'm trying to work out x minus 1 times something is equal to what I started with. And it's quite obvious that x times by x squared will give me the x cubed. So I already know that. And the other interesting thing is minus 1, that times by this number here, has got to give me minus 2. Now what would that do? Oh, I reckon that's a plus 2, because minus 1 times plus 2 is minus 2. And the only thing I don't know is how many x's are in the middle. So we call that kx. And in class, I'll show you how to do that. For now, perhaps you can have a think about how you might work out the value of k, given what I've just done there. This is called the kx method, and when you get good at it, it's much, much quicker. So anyway, that's what we're going to do in class, exercise 4b, and it's all on page 58 of the textbook.